correct.
But if we just put frequency.
Yeah, you'd be fine. Yeah, how easy can you get? What's he doing here? Okay, so once again, there's a number of reasons why we might want to use a multi-factor design. We can look at interactions. That's a big one. Lots of variables might affect it. I like this one in particular, but there's a number of ones that you would have gotten credit for. So this is basically a naturalistic, no, I'm sorry. Yeah, it's observational study. Oh yeah, so this 32 went on to look at the second thing that I said was important for us to have when we were looking for confounding variables. So a confounding variable systematically goes along with the independent variable, but also we have to be able to tell a plausible story about why it might impact on the dependent variable. And so there's other ways you could have said this, but some story, a plausible reason I thought here, how this extraneous variable might affect the dependent variable. And getting that's the key one. So this is just what is the effect of the independent variable on the dependent variable. And the next question I think is maybe a little too wordy, but and again, this goes way back. And it's an important idea really, and that is we can't study everything all at once. So if we want to answer a question of interest, what I call a big question or an important question, then we have to make it precise, or make it the homey terminology I used was, to answer a big question, you first have to make it small, but when you make it small, you haven't answered the whole big question. So it's the make work for psychology props situation. The world is complicated, you're never going to answer an important question. I say never, but rarely with a single study, but we have to make it definite in order to begin to investigate it. When we make it definite, we're probably simplifying it in some way. This is a book question. The third variable problem is an example of. Say again. Yeah. Oops, should have shown that one. So what's a type 1 error? Say it again.
When we reject the non hypothesis
When we should not have rejected it. Yeah, that's a better way to say it. Because we're never going to prove these things, but we could gain evidence in support of them. But anyway, what you said would have been counted as correct. Or something similar. gave away the answer to this one earlier. Measure of the degree of relationship between two variables.
The degree of
Relationship
relationship
between two variables.
of measuring two things.
Yeah, a correlation is always looking at two things.
And how strong the relationship is, right?
Exactly.
So,
Exactly. So,
oh, and also, isn't it like also measure, like how it's on a linear graph, whether it's
yeah,
positive?
you know, I'll tell you a sophisticated answer I would accept. Somebody wrote in there a measure of variability around the regression line. When we talked about that, high correlations, all the gaps are going to be on that line, and the correlation is less and less, as you float away from that line, then you have more variability. So, it's a measure of the degree of relationship, which is itself expressed as how much variability there is between those two measures. That would be a sophisticated answer, but not necessary. Either one's fine. And this is the formula for what kind of z-score I talked about?
Inferential.
The inferential. Again, not every prof makes that distinction, though I'm trying to get them all to. Because I think it is helpful to see the relationship between what I'm calling the descriptive and the inferential z-score. Now, in this exam, there were two forms that actually used different numbers in the two forms here, so I may not have gotten this one, but if we look at this, so here we have a situation in the world and a test result. And from this, what is the base rate of phobia in the population? So we have 100 people out of the 1,000 actually have it, so the base rate is 10%. Is that clear? And then I think I asked, of those people who have the phobia, pardon me, of those people who are said to have the phobia, how many actually have the phobia? Is that clear? So we get a test, and the test tells us that everyone in the bottom row is tested plus for phobia. And 80 of them have the phobia, in fact. But of all the ones the test says have phobia, what's the likelihood that somebody has a phobia? So to answer that question, you have to know the number over here. So you can get that by saying, oh, there's 900 in this column, 740 here, which means there's 160 left over to be in the lower left-hand cell, yes? So when so that means the test is telling us that there's 160 plus 80, or 240 people are said to have the phobia by the test. And how many of them actually have it? 80 out of the 240, or 1/3 of them. So that when the test says somebody has a phobia, it's only right 1/3 of the time. That's the kind of surprising thing here, and why the base rate is such a useful concept to have in mind as we evaluate how good we can predict things. The other exam form had solved the same way, but it had different numbers.